Welcome, beginner Unity developers, to this comprehensive guide on implementing a custom save and load manager in Unity 3D. A robust and efficient save/load system is absolutely fundamental for any game, especially as your projects evolve and grow in complexity, moving beyond simple data storage needs. This tutorial will equip you with the knowledge to build such a system from the ground up. A robust save/load system is crucial for any game, especially as your projects grow beyond simple data storage. As games become more intricate, managing player progress, inventory, and world states efficiently becomes a paramount concern for a smooth user experience and game integrity. While Unity's built-in player prefs is convenient for basic settings like volume or resolution, it falls significantly short for complex data structures and larger, more dynamic game states. It's not designed for the intricate web of data that modern games often require, making custom solutions essential for scalability and reliability. Throughout this guide, we'll explore superior alternatives to player prefs, such as the widely used JSON serialization for human-readable data and binary serialization for potentially more compact and faster storage. We'll even touch upon the exciting possibilities of cloud-saving solutions for cross-device play and enhanced data security. Today, we'll cover the foundational steps, starting with creating appropriate data structures to hold your game's information, then diving into the mechanics of saving and loading that data, and finally, integrating essential error handling techniques to ensure your save system is resilient and reliable against unexpected issues. Let's begin our practical journey by setting up a brand new Unity project. This fresh environment will serve as our sandbox to demonstrate the implementation of our custom save/load system from scratch, ensuring a clear and focused learning experience without pre-existing complexities. Within this new project, we'll create a simple scene. This scene will contain a basic player character, which we'll equip with attributes like health, a defined position in the game world, and a rudimentary inventory system. These elements will represent the core game data we aim to save and load, providing a tangible example for our system. The Save Manager script will be the central hub, the single point of control for all our saving and loading operations. This architectural choice promotes clean code, easy maintenance, and ensures that all data persistence logic is encapsulated in one accessible location within your project. Crucially, we'll utilize application.persistentDataPath as a reliable, cross-platform location for storing our save files. This path is guaranteed to be accessible and persistent across different operating systems and devices, making it the ideal choice for ensuring your game's data is always where it should be, regardless of the player's platform. Now, with our project set up and our Save Manager ready, let's define the fundamental structure for our game's data. This involves creating a dedicated class that will precisely outline what information we intend to save and how it will be organized. We'll create a C# class, aptly named GameData, to encapsulate all the specific information we want to save. This includes critical player attributes such as their current position in the game world, their health points, their accumulated score, and the contents of their inventory. This class acts as a blueprint for our saved game state. It's absolutely essential to remember to mark this GameData class with the system serializable attribute. This attribute is a directive to Unity, enabling its serialization process to convert instances of our GameData class into a format that can be easily saved to a file and later reconstructed, making data persistence possible. Within our GameData class, we'll use appropriate data types for each piece of information. Specifically, we'll employ Vector3 to accurately store the player's three-dimensional position, standard integers for tracking health and score, and a list or array of strings to manage the player's inventory items, allowing for flexible and expandable storage. Next, we will proceed to implement the SaveGame function directly within our Save Manager script. This function will orchestrate the entire process of gathering the current game state and converting it into a storable format, acting as the primary entry point for all save operations.
Inside the SaveGame function, we'll first create a new instance of our GameData class. Following this, we will meticulously populate this GameData object with the current state of our game, retrieving values such as the player's real-time position, their current health, and the contents of their inventory, ensuring all relevant data is captured.
Once our GameData object is fully populated, We'll use JSON utility.toJSON to convert this object into a human-readable JSON string. This method efficiently serializes the object's data into a structured text format, making it easy to inspect and debug if needed, while preparing it for file storage. This generated JSON string is then saved to a file using file.writeAllText. We'll specify the file path using our previously discussed application .persistentDataPath, ensuring the save file is stored in a consistent and accessible location across all platforms, ready for retrieval later. It is absolutely vital to always include try-catch blocks for basic error handling during the saving process. This proactive measure helps to gracefully manage any potential exceptions, such as file access issues or disk-full errors, preventing your game from crashing and providing a more robust user experience. Now that we've established our saving mechanism, let's proceed to create the complementary load_game function within our Save Manager script. This function will be responsible for retrieving the saved data and reapplying it to our game state, effectively restoring the game to a previous point. The very first step within our load_game function is to check if the save file actually exists at the specified path using file exists. This crucial check prevents errors that would occur if we attempted to read from a non-existent file, ensuring our loading process is robust. If the file exists check confirms that the save file is indeed present, we then proceed to read the entire JSON string from it using file.readAllText. This operation retrieves all the saved data as a single string, which is the next step in reconstructing our game state. Subsequently, JSON utility.fromJSON game data takes this JSON string and intelligently deserializes it back into a fully functional game data object. This powerful method reconstructs all the player's position, health, score, and inventory data from the text format into usable C# objects. Once the game data object has been successfully deserialized, we then update our active game state with this newly loaded data. This means setting the player's position, health, and inventory to the values retrieved from the save file, effectively restoring the game to its save condition. Conversely, if no save file is found during the file exists check, we don't simply throw an error. Instead, we gracefully handle this scenario by creating a brand new game data object, which is then initialized with sensible default values, ensuring the game can always start in a valid state, even without a prior save. Just as with saving, robust error handling is also vital here for file reading and deserialization during the loading process. Implementing try-catch blocks around these operations will help us gracefully manage potential issues like corrupted save files or unexpected data formats, preventing crashes and ensuring a smoother user experience. Now that we've implemented both our save game and load game functions, let's transition into the Unity editor to see our custom save and load system in action. We'll set up a simple user interface to interact with our new functionality directly within the game. To facilitate interaction, we'll create two distinct UI buttons, one clearly labeled Save and another Load. We will then meticulously link these buttons to their respective save game and load game functions within our Save Manager script, allowing players to trigger these operations with a simple click. First, we'll actively change the player's position within the scene, modify their health value, and add or remove items from their inventory. After making these changes, we will then click the Save button, effectively capturing this modified game state and writing it to our save file. Now, to demonstrate the loading functionality, after either restarting the game or making further changes to the player's state, clicking the Load button will instantly restore everything. The player character will return to its exact save position, health, and inventory, proving the system's effectiveness. Beyond JSON, consider exploring binary serialization for potentially smaller file sizes and improved performance, especially for very large datasets. However, it's important to note that binary formatter is now deprecated in Unity due to significant security concerns and should be avoided in new projects. For enhanced security and to prevent players from easily tampering with their progress, you can encrypt your save files. Implementing a simple encryption layer, even a basic XOR cipher, can deter casual modification and protect the integrity of your game's data. For more advanced and scalable systems, especially those requiring cross-device synchronization or online features, explore robust cloud saving solutions. Excellent options include Unity Cloud Save, PlayFab, or Firebase, which offer powerful backend services for managing player data securely in the cloud. A good practice is to save different types of data independently. For instance, you might save player progress, such as levels completed and achievements, in one file, while game settings like graphics preferences and key bindings are stored separately. This modular approach simplifies data management and updates. Always prioritize data validation and implement robust error handling throughout your save and load processes. This proactive approach is crucial for preventing corrupted save files, which can lead to frustrating player experiences and potential data loss. Validate data before saving and after loading to catch inconsistencies. Implement save data versioning to ensure forward and backward compatibility when your game updates. By including a version number in your save files, you can write logic to gracefully handle older save formats, preventing players from losing their progress with new game versions. To maintain cleaner and more manageable code, always strive to keep scene management logic entirely separate from your saving and loading logic. These are distinct concerns, and decoupling them makes your codebase easier to understand, debug, and extend in the long run. Saving data in small, incremental chunks, rather than one large block, can significantly prevent noticeable pauses or hitches during gameplay. This asynchronous or incremental saving approach ensures a smoother user experience, especially in games with frequent autosaves or large amounts of data. We've now thoroughly covered the essential steps and best practices for creating a custom save/load manager in Unity. From data structures to implementation and error handling, you have a solid foundation to build upon for your own projects. I encourage you to experiment with different serialization methods, such as JSON or even custom binary formats, and explore various saving strategies to find what best suits the specific needs and performance requirements of your unique project. Practical application is key to mastery. For more in-depth resources, additional tutorials, and code examples related to Unity development and save/load systems, please make sure to check the video description below. You'll find valuable links to further enhance your learning. Thank you for watching this comprehensive guide on implementing a custom save/load manager in Unity 3D. Your engagement is greatly appreciated. Please feel free to ask any questions you might have or share your own insights in the comments section below. Happy coding!